Welcome to homework.
This problem asks us if particles can be diffracted, if they can go through interference, basically, if they can exhibit behavior that is characteristic of waves. In order to answer the question, we need to remember of the quantum mechanics wave-particle duality. And I'm gonna give you a brief explanation by remembering about the de Broglie wavelength. So remember that according to de Broglie, each particle has a momentum p that is equal to Planck's constant h divided by the wavelength lambda of the particle. So this means that even massive particles have a certain wavelength. So an electron, for example, and even you and me, we all have wavelengths associated with our momentum. But of course, since our momentum is m times v, lambda, that is the wavelength, is h divided by mv. So if our mass is very large, or our speed is very large, or even regular speed and masses, so for example, a person that has a mass of 70 kilograms and a speed of 1 meter per second, this would result in a very small value of the wavelength. Because remember that h is 6.63 times 10 to the minus 34 joule second. So in order to make up for this very small number, the mass and or the speed or both must be very small. So usually we don't see wave-like behavior because the wavelength is very small. And in order for us to see wave-like behavior like diffraction and interference, um, a wave must have a wavelength that is about the same, that is about the value of the hole the wave is passing through. So for example, if we have the diffraction phenomenon, where a wave passes through a hole that has a diameter d, then we expect that in order to see the diffraction phenomenon, the wavelength of the wave, lambda, must be of the order of magnitude of d. So it must be about d. Okay, so in principle, we could exhibit wave-like behavior. So we could diffract, we could interfere, but we usually don't do those things. We don't diffract, we don't interfere because we have very small wavelengths. And for example, in order for you to interfere or to diffract when you pass through a door, the door would have to have a width that is very, very small, much smaller than the radius of a typical atom. But electrons, for example, do diffract, they do interfere with each other. So in the end, the answer to your question is yes, they can do both. Both because particles exhibit wave-like behavior. And this is the answer to your question.